Welcome to Spring LIB.
All right, so this is what the diagram looks like. You have a layer of film on top of a layer of glass, each with their own own separate refractive indices, and F for the film, and Ng for the glass. T is the thickness of the film, right? So basically, what happens is that the first ray passes through with no reflection, while the first ray passes through right here with no reflection, while the second ray is indeed reflected, and it's reflected twice, right? So let's look at the two different situations for refractive indices. So in the case that the film has a higher refractive index than the glass, the idea here is that the first reflection from the glass glass produces a phase shift of 1/2 times the wavelength of the film. And then because of the additional path length traveled, you have 2t for the rest of the net phase shift. So your total phase shift is 2t, or your net phase shift is 2t plus 1/2 of wavelength in the film. And then you set that equal to something, right? And so for the maximum intensity, you have constructive interference, and in this case, you have 2t plus lambda f over 2 is equal to m, an integer, times lambda f. And so this gives you t equals lambda f over 2 times m minus 1/2. This is equal to lambda f, or lambda, just the wavelength of light, over 2 times refractive index of the film times m minus 1/2. And so m is just integers, 1, 2, 3, etc. And then in the maximum, and for minimum intensity, you have destructive interference. So you have 2t plus lambda sub f over 2 is equal to m plus 1/2 for destructive times wavelength of in the film. And so here t is just lambda m times lambda over 2 times nf, where m is 0, 1, 2, and other integers. And so we see here that the minimum, and so from this we can see the minimum, occurs when t equals 0. Right, that's when the transmitted beam will be at a minimum. This is one possibility, or the other case is where in the limit that t is much less than lambda over n sub f, as you can see, and so that's when the minimum occurs, right? In the other case, that refractive index of the film is greater than the refractive index of glass. What happens is that now you don't have a phase shift due to the first reflection, and none from the second reflection. And so for the second ray, you do not have the lambda over 2 term, right? For ray 2, you don't have, so unlike in here where you had the 2t plus lambda over 2, you don't have the second term. So all you have for net phase shift is 2t, and that's due to the additional path length traveled by the second ray. That is equal to, for constructive interference, to m times wavelength in film. And this is the maximum case, right, for maximum intensity. And so T, the thickness, is then m times lambda over 2 times refractive index, where m is 0, 1, 2, 3, and other integers. And in the minimum case, you have 2t, again, 2t on the left-hand side, and that's equal to m minus 1/2 times lambda sub f. So t is lambda over 2 times f times m minus 1/2, where m is just integers, 1, 2, 3, etc. And here again, you have, and here this time, the opposite situation to here, where minimum was when t equals 0, or in that limit, you have maximum transmitted intensity when t equals 0, or t is much, much less than lambda over n sub f. And